In this section, we have three goals. We're going to find roots of polynomial equations, factor polynomials by finding the greatest common factor, and then put them both together by solving polynomial equations by factoring first. So roots is a word you might hear pretty often, and all that is the values of x that make a polynomial equation equal 0. A synonym is also solutions. So if you're being asked to solve, what's important is that it has to equal 0 before you're ready to solve, and we'll talk about that later. The zero product property is pretty straightforward. It says that if you multiply two quantities, a times b, and the product is 0, then either a or b must be 0, which makes sense because anything times 0 is 0. So if this times this is 0, then one of them must be 0. The difference is that a and b won't be simple numbers or variables, they'll be binomials or polynomials, so this might be like x plus 1 and this might be like x plus 5. So here we're going to use the zero product property to solve. So our first quantity, if I actually just color code, is x plus 2, which is multiplying x plus 4. Remember, back-to-back parentheses implies multiplication. So there's my multiplication. Here's my first quantity, or my a. Here's my second quantity, or my b. I'm getting 0, so that means either this quantity equals 0 or this quantity equals 0. So I'm going to pull them out. So I'm going to set x plus 2 equal to 0, and I'm going to figure out what x would be to make that happen. So to do that, I isolate x the way I always have, and x equals negative 2. So that's one root or solution. I could actually check that by replacing x with negative 2. And if I did that, I'd get negative 2 plus 2 times negative 2 plus 4. Negative 2 plus 2 is 0, times negative 2 plus 4 is 2. 0 times 2 is 0, so it checks out. So then I'm going to do the same thing, but I'm going to do it for the red quantity. So if I can get x plus 4 to equal 0, I have another root or solution. To isolate x, I'd subtract x from 4 from both sides, and x equals negative 4. And if I plugged that in up here, I'd get negative 4 plus 2 times negative 4 plus 4. Negative 4 plus 4 is 0. It doesn't even really matter what this is. 0 times anything is 0. So they both work. Example, x minus 5 is my first quantity. X minus 1 is my second quantity. So first, if x minus 5 equals 0, and to solve for that, I'd add 5 to both sides. So x equals 5. And then x minus 1 equals 0. Add 1 to both sides. X equals 1. So I have two roots. They're x equals 5 and x equals 1. Pause the video. Try this one right here. Plus press play when you're ready to check your answer. So you have your two quantities set equal to 0. To solve the red quantity, you'd minus 3 from both sides. X equals negative 3. And to solve the blue quantity, you'd add 5 to both sides. X equals 5. The next one, now these you could probably, as you get good at it, you can do it mentally. You might not need to show the work. This one right here, I am going to show the work. So I have my first quantity, 2x plus 1, and I want that to equal 0. So now I'm going to isolate x using reverse PEMDAS. So the first thing I would do is minus 1 from both sides, which gets me 2x equals negative 1. And then to isolate x, I would divide by 2. Then we'll leave it as a fraction. X equals negative 1/2. And then on the next one, 3x minus 4 equals 0. To isolate x, you would add 4. You get 3x equals 4. Divide by 3. And again, I'm going to leave it as a fraction. There's no need to change it to mixed. I can leave it improper as long as it's reduced. So my two solutions are x equals negative 1/2 and x equals 4/3. Try this example over here. The only difference is this time you have three quantities. 1, 2, 3. You're going to have three roots. Pause the video, press play when you're ready to check your answers. So the first quantity that you would pull out and set equal to 0 is 4x. To solve for x, you divide both sides by 4. X equals 0. 3x minus 2 equals 0. You add 2 and then divide by 3. So x equals 2/3. And if 5x plus 4 equals 0, you minus 4 and then divide by 5. So x equals negative 4/5. So factoring means to rewrite a polynomial as the product of two factors. So kind of similar to how you could rewrite 24 as the product of 12 and 2. Those would be two factors, and that's a product. We're just not going to be doing it with a number. We're going to be doing it with a polynomial. In this case, we're going to start with binomials. So we're going to start by looking for the greatest common factor. So what do 12x and 42y have in common that can be divided out? And 12 and 42 can both be divided by 6. So then in these spots right here, you put what would need to go. So that way if you distribute the 6, you'd get back 12x and 42y. So 6 times what would be 12x? That's got to be a 2x. And then 6 times what would be 42y? That's got to be a 7y. So when you factor by using the GCF, essentially you are undistributing. And remember, when you distribute, you're multiplying. So undistributing would be dividing, which also means you can check your answer by distributing. So if I want to make sure that I'm correct, I would just multiply. 6 times 2x, 12x. 6 times 7y, 42y. I'm good to go. On this next example, I'm going to look at the numbers and variables separately. So 4 and 24 have a common factor of 4. X to the fourth really means x times itself 4 times. So if you can picture, x to the fourth kind of means you have 4 x's sitting there. And x to the third means you have 3 x's sitting there. So I need to take the most that I can, but I have to take the same amount from each. So since I can only take 3 from here, because that's x to the third, there's 3 x's to take, then I can only take 3 from here. So I'm going to take out x to the third, and then in my parentheses, I'm going to put what would need to be on these lines, so that way if I distribute, I get back this. So 4x to the third times what would be 4x to the fourth? That's just going to be an x. And then that would be a 6, because 24 divided by 4 is 6. X to the third divided by x to the third is just 1. Remember, anything divided by itself is 1, so all the x's are gone. So here you had 4 x's. We pulled out 3 of them, leaving 1 of them. Here we had 3 x's. All 3 of those x's got pulled out, leaving really a 1. Let's say none. The next example, 14m and 35n, they have a 7 in common. And then to get back the original, you would distribute that to 2m plus 5n. So that's the answer. So you could see in both of these, we now have a product. Here's where the multiplication is happening, at the parentheses, of 2 factors. So 7 is one factor, 2m plus 5n is the other. 4x cubed is one factor, x plus 6 is the other. Pause the video, try the next 4 examples, press play when you're ready to check your answers. So in the first example, 8 and 12 are divisible by 4, so we're going to undistribute a 4, and then dividing each, you're left with 2x plus 3y. So if I distribute my 4 back, I would get back the original. 14 and 21 are divisible by 7. This is y squared, so there are really 2 y's sitting there. 1 y is sitting there. So the most I can take out of both is just 1 y. So I can take out 7y and then 2y plus 3. If I distribute back, I would get 14y squared plus 21y. 6 and 9, you could take out a 3. X squared and x, you can take out an x. Y and y squared, you can take out a y. And then you're left with 2x plus 3y. So 3 times 2 is 6, x times x is x squared, y times 1 would be y. 3 times 3 is 9, x times 1 is x, y times y is y squared. That's the final answer. Another way to think about it is there are 2 x's, I took 1 away, 1 left. 1 y, I took 1 away, no y's there. So really it's an invisible 1. 1 x, took it out, no x's. 2 y's, took it out, 1 y. And then 4 and 2 have a GCF of 2. T squared and t have a GCF of t. 2t times 2t would be 4t squared, minus 2t times 1 would be 2t. Don't forget that when you pull out your GCF, you're really dividing. So 2t divided by 2t is 1. So now we're going to kind of put both parts together, the factoring using the GCF and the zero product property. So solve by factoring first. So the first thing that you had to notice is that solving means to find x when the equation equals 0. So for all 4 of these first examples, the equation equals 0. So we're ready to start. But first we need to factor. So I'm going to factor my binomial by undistributing. So I'm going to take out my GCF of 2x, which means I'm left with x plus 4. And I can check that by distributing. And 2x times x is 2x squared. 2x times 4 is 8x. So I know so far that I have factored correctly. So now I have my two quantities, and I'm multiplying and getting 0. So that means that one of my two quantities, either 2x equals 0 or x plus 4 equals 0. And then I can solve both of those for x by isolating. So x equals 0 or x equals negative 4. So it's a combination of the factoring, which is right here, with the zero product property. So on the next one, if I factor first, my GCF is going to be 3x, which leaves me with x plus 6. So then my first quantity, 3x, could equal 0. Divide both sides by 3, I get 0. Or x plus 6 could equal 0. Subtract 6 from both sides, x equals negative 6. Again, if you want to do this part in your head, that's totally fine. Just be careful as they get more complicated. Try the bottom two. Pause the video, press play when you're ready to check your answer. So on the first one, GCF is a, and you're left with a plus 5. If you distribute, you get a squared plus 5a, so you're good. A can be 0 or negative 5. The next one, your GCF is 3s, and you're left with s minus 3. Again, if you distribute, you get 3s squared minus 9s, so we know we're good there. S can be 0 or s can be 3. These ones are different because now they don't equal 0 anymore. So before we can actually start, I need to make it equal 0. So to do that, I'm going to minus 15n from both sides. And then I'm left with 0 on the right. On the left side, I don't have like terms. So the best I can do is 6n squared minus 15n. Now I'm ready to factor. So my GCF would be 3n. And I'm left with 2n minus 5. And so now my first quantity that could equal 0 is 3n. If I divide both sides by 3, I get n equals 0. Or 2n minus 5 equals 0. And to isolate n, I'm going to add 5. And then divide by 2. So n equals 5 over 2. On the second one, before you start, you're going to get it equal to 0. So you're going to minus 2x from both sides to get to 4x squared minus 2x equals 0. Now you can factor using the GCF, which is 2x, and you're left with 2x minus 1. Remember that if the GCF is 2x and this is 2x, you're really dividing, so 2x divided by 2x is 1. Also, if you distribute, you get that back. So then the two options for x would be 0, or if 2x minus 1 is 0, you'd add 1, and then divide by 2, so x could be 1/2. Pause the video, try the next example, press play when you're ready to check your answer. So first on this example, you're going to minus 14s from both sides, so 4s squared minus 14s equals 0. GCF is 2s, leaving you with 2s minus 7, and then s can be 0 or s can be 7 over 2, because first you would add 7 and then divide by 2. So in the vertical motion model, we have this equation where h equals negative 16t squared plus vt plus s. H stands for an object's height, which in this formula has to be measured in feet. V stands for velocity, which is in feet per second. T stands for time, which is measured in seconds. And S stands for initial height, which is measured in feet. So down here we have a startled armadillo who jumps straight in the air with an initial velocity of 14 feet per second. So if I take my vertical motion formula, h equals negative 16t squared plus vt plus s, I don't know his height or his time, but I know his velocity is 14, so v becomes 14. And because it doesn't say where he started, we can assume that he started on the ground, so s is 0. So I don't need to put plus 0. And then the problem specifically asks, when does he land back on the ground? So when you're on the ground, your height is 0. So I'm going to change h to 0. And now that it equals 0, I'm going to solve by factoring. So I'm going to find my GCF, which is going to be negative 2t, and I'm going to be left with 8t minus 7. And so then my first quantity is negative 2t, and if that equals 0, t would just be 0. Or my next quantity, 8t minus 7, I would add 7, divide by 8. So time, which is seconds, can either be 0 or 7/8. But if time was 0, he didn't do anything. So that's actually the moment that he's starting his jump. So the time that it takes for him to land back on the ground is 7/8 of a second. Pause the video, try the next one with the dolphin. It should be modeled very similarly to the armadillo. Press play when you're ready to check your answer. So if you start with the formula, and then you know the velocity is 32, the initial height is 0, so we don't even need that. Then it's asking for how long does it take the dolphin to re-enter the water. So when he enters the water, his height is 0. You can take out your GCF of negative 16t, which leaves you with t minus 2. So t can be 0 or 2, but t equaling 0 means he hasn't done anything yet, so it must be 2 seconds for the dolphin to re-enter the water. So this problem says 2 rectangular buildings floor plan have different dimensions but the same area. So here's one rectangular room, and here's another rectangular room, and I'm going to find their area, and it says that they're the same. So I can set them equal to each other. So to find area of a rectangle, I do base times height. So on the left side, I'm going to do w times w plus 2. And on the right side, I'm going to do 2w times w minus 1, because it tells me they're the same. Now I'm going to start to simplify that. So I'm going to get w squared plus 2w equals 2w squared minus 2w. My next step, I have to get it equal to 0. And I want w squared to be positive if possible. So I'm actually going to minus w squared, which gets me 2w equals w squared minus 2w. Because remember, that's really a 1. 2 minus 1 is 1. And then now I can minus 2w, which gets me 0 equals w squared minus 4w, because remember that's really negative plus negative. Now I'm ready to factor using my GCF. So 0 equals w times w minus 4. So then w can equal 0, or w can equal 4. But since, based on the picture, w is a dimension, if w is 0, I wouldn't have a dimension here or here. And actually, if it was 0 here, it'd be negative. So w can't be 0, so it has to be 4.